Today we are going to talk about factoring trinomials. So before we were given 4 items and you were supposed to go through and group them accordingly. So if I was to factor this by grouping, I would have grouped 6a minus 4 and 15a squared and negative 10a together. And then you could pull out or factor out a2, leaving you with 3a minus 2. And you could factor out 5a, and that leaves you with 3a minus 2. And then you're supposed to make sure that your parentheses said the same thing. That means you're doing the right steps. And then your last step was to pair your GCFs together. And then just throw one of your 3a minus 2s. So that was one scenario of factoring. The other scenario was when you did have a GCF that you could have taken out from the very beginning. So the way we were taught to do that is to actually factor out the GCF, which we know is going to be 2. So I guess I'll actually do this just to stay consistent here. And then you were taught bring the GCF to where you're going to write your answers so that you don't forget about it. And then we'll just look at the rest of what's in the parentheses. And then when you group these, you're supposed to be careful. You can't split the negative from the 4. You have to group the negative within and just put an addition sign between the two so that they remain separated. So it looks like you can factor an a out from the first group and a negative 4 from the second group. Oh. Oops. I wrote a plus here and that should have been a minus. There, now that makes sense. So we get actually a positive here now. All right, so my parentheses do match up. And last but not least, going to group them together. Okay. And that's how we factor by grouping. So we are going to need these steps and what we learned today, but we have an additional step. So consider having a trinomial, and this is the last kind of polynomial that you have to graph. You have to factor. We never go above 4 terms in Algebra 1, so 4 or less is what you have to factor. The first thing I always do is rewrite my polynomial in descending order, unless it's there already. Clearly, it's not in descending order. We want our a squared term to be first, our a term to be second, and our constant to be last. So that's step 1, pretty easy. Step 2 is you're going to multiply the leading coefficient. And if you don't know what that is, that's the number in front of the x squared, or in this case, a squared term. So it's the coefficient of the highest exponent. So you're going to multiply your leading coefficient with your constant. We're then going to make an x, and we're going to place this product that we get in the top of it. So just so we're all on the same page, 15 would be our leading coefficient. Negative 4 is the constant, and a constant, just to remind you, is a number with no variable. I'm going to go ahead and make my x. And in the top, I'm going to do 15 times negative 4. So if you have a minus sign or a negative in front of something, then make sure you use that as a negative 4, not a 4. 15 times negative 4 is negative 60. So that goes in the top of my x. Step 3 is we're going to place the middle coefficient in the bottom of x. And if you don't know what that is, that's going to be the number that is in front of your a or your x or your p term. So it's the one that would be in the middle in descending order, hence the name middle. So in this case, negative 4 happens to also be the middle coefficient. So that's going to go down here. And again, that's coming from the middle. So that goes down here. This should look kind of familiar. This is why we were doing diamond puzzles, so that we could train ourselves to be ready for this situation. So we have to think of two numbers that multiply to get us negative 60, but add to get negative 4. So I know that 6 times negative 10 does equal negative 60. It just has to also add to make negative 4. So now I'm going to do 6 plus negative 10. And I do get negative 4. So lucky guess that those were the two numbers that work. So we call those our mystery numbers. And that's step 4. So we're just going to put 6 and negative 10 in our x. You could have these reversed if you'd like. It's not going to change the outcome. And what we're going to do is we're basically going to copy our original problem, but we're going to include the 6 and the negative 10, and here's how we do it. So 15a squared is going to remain the same, but I'm going to change the middle into positive 6a, that's the 6, and negative 10a. So I incorporated my mystery numbers in here, and your last original number will stay put. So in other words, you will always keep the first and the last, and only the middle changes. And if you guys want to check, if I told you to simplify that, you do get 15a squared minus 4a minus 4. So we have not changed the problem. We're just creating it, we're just rewriting it so that it's workable. Okay, but we have not changed. We haven't broken any rules of math. We haven't changed it. We're just rewriting it. And then you should be able to handle it from here. So we're going to group. And again, include the negative with a 10 and just simply put a plus sign to separate the parentheses. From 15 and 6, you can factor out a 3. You can also factor out an a. And that leaves you with 5a plus 2. And from the second group, I can factor out a negative 2. And that leaves me with 5a plus 2. So my answer is going to be 3a minus 2 times 5a plus 2. So I realized that that was a lot of steps, and it's going to take some practice problems for it to sink in, but it's really not a difficult task. You'll eventually get the steps, like you just start to do them automatically. It's not too bad. So we'll just do 2 examples to start off and take it one step at a time. So I have a trinomial. First things first, there's no GCF, so nothing I can factor out. So what I'm going to do is go straight into making my x. I can't group yet, don't have enough to group. And you can't forget there's really a 1 out here. So 1 times 15 will make 15. And that goes in the top. Your middle coefficient, which is 8, will go in the bottom. And now you need to complete the diamond puzzle. So it's not too terrible. Your numbers are going to be 5 and 3. And now it's time to rewrite. So you leave a squared alone. Instead of 8, we're going to change it into 5 plus 3. So we have 5a, 3a, and you leave the 15 alone. So again, you always keep the first and the last items. Only the middle breaks apart. So if that helps, you can see it like that. All right, and then we're just going to group. Hopefully you end up with a plus 3 times a plus 5. And remember, if you're never sure if it's right, you can go ahead and distribute or FOIL and make sure that you end up with the beginning problem. Number 2 is almost the same thing, except it's not in the correct order, so I would like to rewrite it as t squared plus 10t plus 9. There is no GCF that I can factor out, so I have to go right into my x. Again, can't group yet. I don't have enough terms. And we're going to do 9 times 1 and get 9. The middle is 10. And then I think of my numbers, that'll work. And I know that there's only two things that can get you 9. It's 3 times 3 or 9 times 1. Well, 9 and 1 make 10, so that's clearly obvious. Time to rewrite, so keep your t squared term. We're going to break the middle into 9 and 1. And you keep the last term. And now it's a review problem. So I get t plus 9. Remember, if you don't have anything in common, you always have a 1 you could use, and you do have to take out a 1. So my answer is t plus 1 times t plus 9. Number 3, we have to pull it up before we go right into making an x because there is a GCF. We have 2, 44, and 42, so I am going to factor out a 2. And just so I don't forget about it, I'm going to go ahead and put 2 in the bottom where I'm going to write my answer. I'm gonna, instead of rewriting this, I'm gonna just do the whole x thing so I can kind of do 2 steps in one here, just to save room. All right, so 21 times 1 gets me 21. In the middle is negative 22. So if I need to multiply, get a positive, but add to get a negative, I'm gonna have to figure out 2 negative numbers. So I know that basically 21, you could pick 7 and 3, but that can't make 22. The only other option you have would be 21 and 1, and that does work. So a lot of this is going to depend on your multiplication skills and your knowledge of negatives. So now I'm going to rewrite actually a 4-term polynomial. Keep the m squared, break the middle to 21 and negative 1, and keep the positive 21 at the end. All right, now we're going to group. Looks like I can take an m out, and I can factor out a negative 1. And the reason I took a negative 1 out is because I want this to become positive so it matches up with this m. Good, matching parentheses. Time for our answer. We have m minus 1, m minus 21. And we're done. So what we're going to do is I'll get you started up to the point where we set up a 4-term polynomial, and then you can pause the video and then unpause and see if your answer matches mine. So I'm definitely going to take or factor out a 2, and I'm left with 3y squared minus 2y minus 16. I'm going to bring the 2 down, make my x. Be careful, you're actually doing negative 16 times 3. So just make sure that you're aware of that negative. You get negative 48. And the middle coefficient is negative 2. So if you think, what can multiply to make negative 48? So we're looking for a negative and a positive number. And that combo, since it has to add to a negative, would have to be negative 8 and positive 6. So I'm going to rewrite 3y squared minus 8y plus 6y minus 16. And that's all the furthest I'm going to do that one. I'm going to actually jump to 5 to help make sure that we're both in agreement. And then you can pause the video and try it for yourself. So you can definitely factor out a 3, leaving us with x squared, 2x, and negative 15. Bring 3 down. My x. Negative 15 times 1 is negative 15. 2 goes in the middle. So I know I'm going to have a positive and a negative since my product is negative. And it looks like that combination is going to be positive 5 and negative 3, so that I get positive 2 when I add. I'm going to rewrite x squared plus 5x minus 3x minus 15. So go ahead and pause and try factoring by grouping, and then we'll see if you have it. Okay, take a look and see if your answer matches with mine. Go ahead and try example 6 completely by yourself, and then pause the video. When you unpause, it'll be done. All right, you can go ahead and take a look and see if you got h plus 3 times 2h minus 5, and if you did, good job. The last thing we're going to talk about, this doesn't take very long, is the zero property. Keep in mind, if you want to multiply and get 0, then you have to have 0 to do that. So just food for thought. So if I want to get like some 0 as an answer to a multiplication problem, you're either going to have to put 0 here or 0 here. But one of these numbers has to be 0. Both of them could be, but at least one has to be. So in order to solve a quadratic is basically an x squared problem. So when I see x squared, I call it a quadratic. And it's an equation, so now we're going to have an equal sign, and you guys know if you have equal signs, then you can solve for a letter. The biggest rule is you have to have 0 on one side of your equation. That is very, very important, or it's not a legit answer. And a lot of kids forget this. It's basically a couple steps. You're going to factor like we were doing. You set each group equals 0, and then you solve. So it's not too terrible. So like number 7, if I make my x, I know that 1 times 6 is 6, and I get 5. So 3 and 2 are going to work. So I have x squared plus 3x plus 2x plus 6 equals 0. And all you got to do is basically just keep the equal 0 for now. And you do all your factoring first. And equals 0 plus 2 times x plus 3 equals 0. So I kept that equals 0 there the whole time because a lot of kids forget about it. You are not done because this does have an equal sign. You need to solve. So all you really have to do is take each parenthesis, which includes x plus 2 and x plus 3, and you're just going to set each one equal to 0. So these are very, very simple equations. I know that in this case, x equals negative 2, and in this case, x equals negative 3. So usually you get 2 answers for these because there's 2 things that could go into x to make this a true statement. And you can always plug them in and try it, but it's going to work. Number 8, you have to freeze. This is a big problem right now because we don't have 0 over here. Easily fixed though. We're just going to subtract 27 first. And rewrite this as t squared plus 6t minus 27. Now it equals 0. Now you can go ahead and factor. My numbers, in this case, I need a negative and a positive, so I'm going to have negative 3 and positive 9. T squared minus 3t plus 9t minus 27, keeping that equals 0 the whole time. Apologize, my handwriting's not the best here. Alright, so all of this is the same. This is the part that's new, but it's not hard to do. So t plus 9 could equal 0, or t minus 3 could equal 0. Both would work. So if I used negative 9 or positive 3 in this equation, I would get 27. You can try the last one on your own. It's basically the same as the problem I just did before, and then check your answer with mine. When I worked this out, I ended up getting m plus 6 times m minus 11, therefore making my answers -6 or positive 11. So we have to take both answers because both of them make this equation true. So just remind yourself, when you have, I always look at, if my degree is 2, I should usually get 2 answers about 90% of the time.